Next, let's talk about using groundwater. Groundwater in an aquifer is like money in your bank. Each time you put money in your bank, the amount of money you have grows. When you withdraw money from your bank to buy something, for example, your bank account goes down and stays down until you put more money in. It's kind of like this.
You can think of groundwater in an aquifer as money in your bank account. Each time you put money in, the amount of money you have grows. When you take money out, your bank account goes down and stays down until you put more money in. Aquifers grow when nature puts water in through rainfall, snow, and other precipitation.
Water leaves the aquifer naturally along streams and springs and through other openings. Humans greatly increase water withdrawals by drilling wells into the aquifer and pumping water out. Just as withdrawing money from your bank account depletes the money you have for future use, withdrawing groundwater without equal or greater deposits of rain back into the aquifer depletes the groundwater supplies. The size of the aquifer and how full it is determined by how much water it's holding at any point in time. The porosity of the aquifer determines the rate at which water can move through or into the aquifer. Some aquifers refill rapidly. So if there is sufficient rainfall in the aquifer area, the amount of time needed to recharge the aquifer may be quite short. The Edwards Aquifer, for example, can recharge quite quickly. In some places, water in the Edwards Aquifer can move as far as 8 miles in a single day. Now, water may take hundreds or tens of thousands of years to move that far in other aquifers. The Edwards Aquifer can also be emptied rapidly if the groundwater is not conserved. Other aquifers, such as the Ogallala, have an enormous capacity to store water but can take very, very long to recharge. Water taken from aquifers that recharge slowly is almost like mining a non-renewable resource such as coal or copper. Once water is taken out of these kind of aquifers, recharge will take so long that for all practical purposes, the aquifer is no longer of use to humans. Water from the Ogallala is now being pumped out by nearly 200,000 irrigation wells, with the highest rates of pumping generally occurring during the driest years. In southern parts of the aquifer, pumping has already lowered the water table by as much as 200 feet in some locations. Pollutants, such as gasoline, oil, runoff from roads, fertilizers, and chemicals, can seep into the groundwater. Sources of groundwater pollution include hazardous waste sites and landfills. Aquifers act like natural filters that trap sediment and other particles. They provide natural purification of the groundwater flowing through them, so water coming out of an aquifer is usually cleaner than when going in. However, many dissolved substances may not be filtered by the aquifer. Despite natural purification, groundwater can become polluted. Natural concentrations of some contaminants can be high. For example, some groundwater just contains naturally high concentrations of things like iron, hydrogen sulfide, salts, magnesium, uranium, and even arsenic. Sometimes groundwater must be treated through special processes so humans can safely use that water. Now, due to the increasing loss and contamination of this special groundwater and aquifer habitat, many of Texas's unique spring and underground dwelling species have been declared by government agencies to be threatened or endangered with extinction.